Single variable calculus assignment help. For any assignment-related queries, call us at +1 678 648 4277. You can mail us at support@mathhomeworksolver.com or reach us at https://www.mathhomeworksolver.com. Part 1. These problems are mostly from the textbook and reinforce the basic techniques. Occasionally, the solution to a problem will be in the back of the textbook. In that case, you should work the problem first and only use the solution to check your answer. Part 2. These problems are not taken from the textbook. They are more difficult and are worth more points. When you are asked to show some fact, you are not expected to write a rigorous solution in the mathematician's sense, nor a textbook solution. However, you should write a clear argument, using English words and complete sentences that would convince a typical calculus student. Run your argument by a classmate. This is a good way to see if your argument is reasonable. Also, for the problem graders sake, try to keep your answers as short as possible, but don't leave out important steps. Part I, 20 points, A, 4 points, P, 170, Section 5.2, Problem 12, B, 4 points, P, 177, Section 5.3, Problem 45, C, 4 points, P, 206, Section 6.5, Problem 1, D, 4 points, P, 212, Section 6.6, Problem 4, E, 4 points, P, 213, Section 6.6, Problem 30. MathHomeworkSolver.com. Solution to UB. We start by rewriting then do equals 2x dx, and our integral becomes back substituting gives. Solutions. Solution to SE and SN equals AMAX equals using the summation formula. 4. On page 195 of the textbook, we K equals 1n and obtain. As n infinity solution to D, we first find the zeros of 4 times 2 plus 9y is equal to 36 to determine the integration limits. Thus, we let y equals 0, and solve 4 times 2 is equal to 36, to find the points x equals plus or minus 3. Therefore the area is given by the integral. MathHomeworkSolver.com. Where we used the equation 4 times 2 plus 9y is equal to 36 to express y in terms of x. The integral 1 can be evaluated easily as solution to E let u equals x2 plus b2, then do equals 2x dx, u0 equals b2 and u2b equals 5b2. Therefore part 2 problem 1a function f x is defined for all x greater than 0 to be, using the fundamental theorem of calculus, compute df/dx. Do not attempt to evaluate f x directly. Solution to problem 1 let u equals square root x, and g, u, equals 0 e minus t2 dt equals f x. By the chain rule. MathHomeworkSolver.com. By the fundamental theorem of calculus, we have dg equals e minus u equals e minus x. Therefore do. Problem 2 using the definition of the Riemann integral, upper sums, and the formulas for special sums in the textbook, compute that. For all a greater than 0. Solution to problem 2 since the function f x equals a minus x, a plus x equals a 2 minus x2 is even, we can rewrite the given integral as. We partition the interval 0, a uniformly, i.e. by xk equals ca, into n equal subintervals, each of which na has length n, remembering that we are required to compute the upper sums, we calculate therefore. MathHomeworkSolver.com. Hence, problem 3 this problem is a special case of a more general method for computing antiderivatives that will be developed systematically later in the semester. A. Compute the antiderivative 1 minus 1 u2 do as follows. Consider the sum plus u minus 1, where u plus 1a and b are unspecified constants and clear denominators. Find a choice of a and b so the sum 1/8b simplifies to 1 minus 1 u2. Now replace 1 minus u2 in the integrand by your expression plus u minus 1. Use ln u plus 1 ln u minus 1 to compute the antiderivative. Solution to a. Following the hint, we let. Therefore, we must have. Solving this set of equations, we obtain a equals b equals 1/2. In summary, mathhomeworksolver.com. Therefore, b. Reduce the computation of the antiderivative cos x dx to a by multiplying numerator and denominator of the integrand by cos x using the trig identity sin x 2 plus cos cx 2 equals 1 and substituting u equals sin x. Don't forget to back substitute. Also, say for what range of x your antiderivative is valid. Ln y isn't defined if y is negative. Solution to b. Following the hint. We let u equals sin x, then do equals cos x dx, and the indefinite integral, 4, becomes mathhomeworksolver.com. Because of the absolute values, the argument of the logarithm never gets negative. However, it still vanishes when 1 plus sin x equals 0, i.e. when x equals pi minus 2 plus 2 pi n for integers n, and still becomes singular, goes to infinity, when 1 minus sin x equals 0, i.e. when x equals function will be truly so on any interval which does not contain plus or minus. Such domain would be the open interval. mathhomeworksolver.com